A programmable logic controller, or PLC, is the backbone of industrial automation. A PLC is basically a computer. However, it is a designated computer that is used for specific functions. The PLC receives information from connected sensors or input devices, processes the data, and produces outputs based on pre-programmed parameters. Although there are a multitude of PLC manufacturers, most PLCs contain the same basic components. Depending on the inputs and outputs, a PLC can monitor and record runtime data such as machine productivity or operating temperatures, automatically start and stop processes, generate alarms if a machine malfunctions, and more. Programmable logic controllers are versatile and suitable for almost any automation application. Although PLCs are capable of performing a multitude of automation functions, the four basic functions of a PLC are controlling discrete inputs, discrete outputs, analog inputs, and analog outputs. In the example, the four basic functions of a PLC are shown. The PLC monitors the discrete inputs of the push buttons, produces a discrete output to control the motor starter, produces an analog output to control the variable frequency drive, and receives analog input information for system control. There are two basic types of PLCs: self-contained and expandable. The self-contained PLC is typically limited in its capabilities and used for smaller automation systems. Although a self-contained PLC is small and compact, it is very powerful and may contain some of the same control features of a larger PLC. The expandable PLC is typically used for complex control systems. An expandable PLC uses a backplane that allows for the addition of specific control modules. Each module receives power from the backplane and communicates with the CPU through the backplane. PLCs are programmed using software. The computer software is used to develop programs for the PLC. The program is then downloaded to the PLC. Each PLC manufacturer uses proprietary software, which means that the PLC can only be programmed with the manufacturer's software. There are several programming techniques recognized by the IEC.
The IEC recognizes 5 standard programming methods: structured text, ST; sequential function chart, SFC; function block diagram, FBD; instruction list, IL; and ladder diagram, LD.
Although each programming technique has its use, ladder diagram programming is by far the most common method used. Ladder diagram programming is typically the easiest programming method and can be used for most automation systems. A program is downloaded to a PLC with a communication cable. Although there are various types of communication cables, Ethernet is becoming the preferred communication method used to communicate with the PLC. A programmable logic controller is both versatile and reliable. It is a powerful tool and is the backbone of modern automation systems. PLC structure, design, terminology, and programming techniques are essential skills for the automation technician.